coding hands-on in Rust programming language. So first, we need to talk about integers. So you all may know what are these and what it can do. So I8, U8, I16, U16, and so on and so forth. They have differences in size. So some integers take up 8 bits, means the integer can be one of 2 to the power of 8 possibilities, aka 256 numbers, and some take up 16 bits, means it can store up to 65,536 numbers, and so on and so forth. But you don't have to remember those possibilities or those numbers. Just look at these code. Alright, we use the type, add in 2 colons, and then min to get the minimum value out of this type. Let's run this code and you can see the minimum value and the maximum value of these type. Okay, we got it. Okay, and now let's do some addition or subtraction with integers. So I assign 12 for the number A, and assign -2 for the number B. And for this line of code, the compiler will throw error. And what we do wrong here is to assign -2 to the unsigned 8-bit integer. Let's run this code and we'll see the error. It cannot apply. An unsigned value cannot be negative. So we should remove the sign because it's unsigned. Now let's run the code. So the result should be 14. Okay. Now we try to minus this. It also should be 10. Great. Let's move to the second example. Is we got multiple ways to declare integer. So to declare a type, we can add a colon after the variable name, like so this variable is I128. Alright, and there's an alternative way for declaring type for numbers. So what you can do, you can say the type after the number. So here's my number, so I can say it's going to be a I128. Right, and this code should work normally. So if you want to make the number easier to read, you can also add the underscore inside the number. So that's the magic of Rust. This underscore sign does not change number. It is only make it easier to read. And it doesn't matter how many underscores you use, it will stay the same, and it just makes things become easier to read. Yep, it still works. Next one is float compatibility with floating point numbers. Okay, there's one small caution on float 32 and float 64 is that they cannot do addition or subtraction or any kind of mathematics with each other. So what we're going to do is to combine these two floats. So we got number A and number B, which have different float type. So let's run this code. The trait at F64 is not implemented for F32. Right? It's very clear. And what we should do, first of all, so we keep them in the same type. They're gonna be 64, or we can even get rid of one. And Rust is smart enough to turn this a F64. So let's run the code. 0.1 plus 0.2 and it gives this very interesting error. So you may ask why this error happens. I'm gonna explain this in the next example. And the very brief reason is that 0.1 or 110 in binary is an infinite sequence like this, just like 1/3 in decimal system. So likewise, 0.2 is 0/10 in binary is this number, this binary infinite sequence. So numbers with infinite sequences can never be represented exactly, and so what do you get? You get a number close to the actual number and not exactly identical to that number, so they are different. So 0.1 in floating point, 0.1. So 0.1 in floating point isn't exactly 0.1 but another number, a number as close to 0.1 as the computer can get. So when you add these numbers, those errors occur, right? You add this to this, it's the same as you add this to this, so the error occurs. And so 0.1 plus 0.2 does not equal 0.3. It's like many computers and any other programming languages. The first solution would be, don't do float, do integers if you want to calculate things. So that's why people don't count decimal for money, they count cents to dollars. So use integers for the exact. And the second solution, if you still want to do addition or subtraction and so on, there's a crate that can handle that called decimal, and I'm gonna explain what crate. So crate is just like npm for those who are familiar with JavaScript, but I'm gonna talk about crate later on. A very quick fix is to turn float 46 to float 32.